on the screen. Yes. Okay, so now we are going to move forward with our last topic for this course, networking 2. So we already finished our lessons, and we are now going to the server load balancing. So now in this last lecture, we cover network load balancing concepts and what is load balancing, what are the functions of load balancer, load balancing algorithms, and the benefits of load balancing, and why are we doing balancing. So network load balancing allows you to simplify your workload in your network. So in this figure, a switch allows packet of information travel through networks with many different paths between them. So load balancers lived as hardware in private data center, but load balancers have evolved, often referred to as application delivery controllers or ADCs, which provide additional capabilities like security, acceleration, and authentication. So now, nowadays, mostly we are using software for load balancers. Rather in the old time, in 1990s, we used still hardwares. Now, what is load balancing? So, load balancing refers to the efficiently distributing incoming network traffic across a group of backend servers, also known as a server farm or server pool. And a load balancer acts as the traffic cop or a police sitting in front of your servers and routing clients' requests across all servers, capable of fulfilling those requests in a manner that maximizes speed and capacity utilization and ensures that no one server is overworked, so which would degrade the performance. So the main purpose of having load balancer is to make the system work but not overwork. So if a single server goes down, the load balancer redirects traffic to the remaining online servers. When a new service is added to the server group, the load balancer automatically starts to send requests. So that is a load balancer or load balancing. So what are the functions of load balancer? So it distributes client request or network load efficiently across multiple server. So in this example, we have figure 2. So you have the clients, and your client's going to access internet. And in this case, you have two options. So you have software load balancer and you have hardware load balancer. So in this way, this would be carried by your application servers that will provide the user with the specific application. So it ensures high availability and reliability by sending requests to only servers that are online. Provides also flexibility to add or subtract servers as demand dictates. So there are different load balancing algorithm. So these provide different benefits. So the choice of load balancing method depends on your needs. So we have the few example in this lecture. So we have round robin, we have least connections, we have least response time, we have hash, we have IP hash, and also we have the power of two random choices. So what is run round robin. So requests are distributed across the group of several servers sequentially. So we have least connection. So a new request is sent to the server with a few connection. So this allows you to decrease the computing capacity because you're just looking for the least connection. And you could use the other connection for another computer. So, and for the least response time, so this send request to server selected by the fastest response time, and there are fewest active connections. So if you have this fast response time, so it would direct the computer to the server if you configure it to at least least response time. So in this setting, the computer will only connect or will provide data for those computer with has least response time. You have hash. So this distributes requests based on the key you define, such as IP client or URL or uniform resource location. And you have IP hash. This use IP address of the client to determine the server, which server receives the request. Also, we have the last. We have these are only the some of the examples of the algorithm, but we have power of two random choices. So you're going to pick two servers in random and sends the request to one that is selected by applying the least connection algorithm. So most commonly nowadays we use a least connection algorithm to provide better load balancing. So round robin. So this is one of the easiest to implement and conceptualize. So it's most widely deployed load balancing algorithm. Using this method, client requests are routed to the available servers on a cyclical basis. So a round-robin server load balancing works best when servers have roughly identical computing capabilities and storage capacity. So the biggest advantage of round-robin load balancing is that it is simple to understand and implement. However, the simplicity of round-robin algorithm also becomes the disadvantage because many load balancers uses weighted round-robin and more complex algorithms. So the round-robin load balancing is the simple way to distribute client requests across a group of server. So, for example, a client request is forwarded to each server in turn. So we have first, second, third, and the algorithm instructs the load balancer to go back to the top of the list, and repeat it again. So after it is distributed, so the algorithm instruct the load balancer to go to the first and to the top to check which server is that and go back again and check which one server is that, is either one or two or three. So that's how round robin works. So it's like cyclical method of selecting your server to which one you're going to balance. So you have the least connection. So load balancing is a dynamic load balancing algorithm where the client requests are distributed to the application server with the least number of active connection. So for example, this one is active, this one is active, this one is active. So which one have the fewest connection? So for the fewest connection, you have a few requests. So you have this weight is two only. Yes. So this have the few requests, and you have also responses. So we have service one. Now for this response time, so when a load balancing virtual server is configured to the use this method is that there will be fewest active connection and the lowest average response time. So the lowest average response time, so we have 4, 8, 6, 6. So we have the response time of these two. Active transaction is 3. So we have HTTP1. So we have 4. This is 5. This is 5. So there are 4 responses for service 1. So this is the small response time. Next is we have the hash. So a hash is a shorter and easier to use than the information that they are based on, while retaining enough information to ensure that no two different pieces of information generate the same hash. So if they're going to generate the same one, so it's going to create confusion. So hashing load balancing methods in an environment where the cache server serves as a wide range of content from the internet is a specified origin servers. Caching request reduces request and response latency and ensures better resource utilization, making caching popular on the heavy used websites and application server. So these sites also benefit from the load balancing in the hashing load balancing methods. They are also widely useful in the web. So these are hashes, hash 1, hash 2, hash 3. So it depends how you're going to implement the hash. So it also means it can reduce downtime and request. So at hash 1, you have fewer requests, and hash 2, you have more requests. So IP hash is a IP load balancing use algorithm to take the source and destination address of the client and server, generate a unique hash key. This key is used to allocate the client to a particular server, as the key can be regenerated if the session is broken. So the method of load balancing can ensure the client is directed to the same server that it was using previously. So this is useful if it is important that the client should connect to a session and after the disconnection and reconnection. An example, this is two random choices. So this principle decides which server will respond to each request by picking two random servers from the fleet, choosing one which have the fewest connections. So in this case, if you're going to select only server B or server C, so mostly people will go to having the least active connection, while this one they try to not able to select this server C because there are more active connection. So, but Power of 2 is efficient to implement, so you don't have need to compare all queues. So what you need to do is to compare is that it works better scale up and best choice algorithm, so it avoids undesired herd behavior by the simple approach of avoiding the worst queue and distributing traffic with a degree of randomness. So not all of the time you're just going to select server B, but if the algorithm decides that this already match the active transactions, so in turn you could choose C. This is how the power to random choices generate algorithm. Now, what are the benefits of load balancing? So first, why we are going to use load balancer? So we need to use it to reduce downtime, also to have scalable, to migrate to a better network, also to check redundancy for the errors. This makes your This would allow you to send data with a clean, with lesser error, and also flexibility and efficiency. So for the summary, so load balancing is the process of distributing workload evenly across multiple servers due to high traffic in websites. So a load balancer acts as a traffic loop, traffic cop, sitting in front of your servers and routing client requests across all servers. A load balancer performs the following functions. It distributes client requests or network load efficiently across multiple servers and ensures high availability and reliability by sending requests to only servers that are online, and provides the flexibility to add or subtract servers as demand dictates. So load balancing benefits. So we have reduced downtime, scalable redundancy, flexibility, and efficiency. I think we are done with our lecture. And now we try to have our simple game or our interactive. Try this one. Okay, so please write your student ID. This would be considered as your participation and recitation. So don't worry if you have difficult connection. So because I will give you the link. Okay, so we'll just mute because to reduce echo. We'll mute because to reduce echo from your phone. Congratulations for those who are top three for the answering the questions. And we're going to end our lecture for today. And thank you for your participation. Any more questions?